morning to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of Computer Science and Engineering. So we are going to discuss about the lattices in discrete mathematics. So what we are going to discuss means what is meant by lattice, and we can understand that lattice with the help of example. So what is the definition of lattice? A lattice is a poset. L less than or equal to is a poset. In case of lattice, for every pair that means A comma B belongs to lattice has a least upper bound denoted as A union B and greatest lower bound denoted as A meet B. This is called as a meet. This is called as a join. So every pair consisting of a greatest lower bound, which can call it as GLB, and least upper bound LUB. So this consisting of meet and join for every pair. Meet and join for every pair. Then we can call it as a lattice. Then it is called as a lattice. LUB is called as a join and the greatest lower bound is called as a meet. This is meet. This is join. So for every element or every pair consisting of a greatest lower bound and least upper bound is exist, then A comma B is said to be a lattice. So this is the ordered pair A comma B. So this is the A and B. That is the greatest lower bound. It is a lower bound. It is a present in the lower way. So it is a and B. So A and B. So that is nothing but a least upper bound. It is a upper bound, but it is a least. It is a lower, but it is a greatest lower bound. For every pair of elements, there exists a meet and join. That means greatest upper bound, greatest lower bound, and least upper bound is exist for every pair of element. Then we can say that it is a lattice. Consider we are going to discuss one example D6 and this operator is a lattice. What is this operator? Is a divisibility operator. Is a lattice. We know that what are the divisors that are divide 6. 1 divides 6, 2 divides 6, 3 divides and 6 divides. Is a poset. We need to check for every pair of element there is a lattices exist or not. Lattices exist not. 1 divides 1. So 1 is the relation. Then after that 1 divides 2, 1. Then 1 divides 3, 1 divides 6. Then 1 divides 6. Again 2 divides 1, 2 divides 2, 2 divides 3. Then 2 divides 6. So we need to consider for every pair of elements. So that is a 1, 2, 3, 6. So 1, 2, 3, 6. We need to draw the lattice. Lattice consisting of a hash diagram 1. So first we need to draw the hash diagram 1, 2, 3, 6. This is a lattice. This is a lattice. Next we need to consider the greatest lower bound 1, 1. 1, 1. So the greatest lower bound is 1 only. Next 1, 2. 1, 2. Lower bound is 1. 1, 3. Lower bound is 3. Next, after that 1, 6. Lower bound is 1. Next, coming to the second line. 2, 1. 2, 1. Lower bound is 1. 2, 2. That is itself is a lower bound. 2, 3. So, 2 and 3, the common lower bound is 1. Common lower bound is 1. 2, 6. 2, 6. 2 joins here, 6 joins here, lower bound is 1. Lower bound is 2, 6. Lower bound is 2. Next, 3, 1. Lower bound is 1. 3, lower bound is 1. 3, 2. Where it joins 1. Next, 3, 3. Itself is a lower bound. Next, 3, 6. This pair, lower bound is 3. Next, again, 6, 1, lower bound is 1, 6, 2, lower bound is 2, 6, 3, lower bound is 3, 6, 6, lower bound. So, in the case of this GLB for every pair, that means 1, 1 or 1, 2, 1, 3, 1, 6. For every pair of elements, there is a lower bound is exist. In the same way, we need to verify the greatest, lower, that is a least upper bound. We need to verify the upper bound. It is a lower bound is exist. We need to verify the upper bound. Upper bound means it is a element which is present on the upper side. 1, 1. Upper bound is 1 only. 1, 2. Upper bound is, this is the upper bound. 2 is the upper bound. 1, 3. Upper value is 3. 1, 6. Upper value is 6. Next. 2, 1. 2, 1. Upper bound is 2 only. 2, 2. 2 only. 2, 3. 2, 3 meets at 6. This is the upper bound for 2, 3. That is 6. Next. 2, 6. 2, 6 upper bound is 6 only. Next 3. 3, 1. Upper bound is 3. Upper bound is 3. 3, 2. For these 2 points, the common value is 6. That is the upper bound. Next 3, 3. That is the 6. 3, 6. Upper bound is 6. Next for 6. 6, 1. Upper bound is 6 only. 6, 2. Upper bound is 6. 6, 3. Upper bound is 6. 6, 6 upper bound. So, in the case of this example, for every pair of elements, there is a least upper bound is exist, then greatest lower bound is exist, then D6 is said to be lattice. What is meant by lattice means for every pair of elements, A comma B belongs to L. When we can say that A comma B belongs to L, there exists least upper bound and greatest lower bound is exist for every pair of element. Then we can say that the relation is a lattice. So what is in this video we discussed about what is meant by lattice, what is the definition of lattice. We can understand the definition by taking the example. Thank you.